Assalamu alaikum wa rahmatullah everyone. Welcome to another video and tutorial which I'm trying to explain regarding the electrical engineering and electrical engineering design in general. But what I would like to talk today is a brief video regarding cables and wires. It will be a general explanation for beginners, simplified explanation in part 1. And in part 2, I will talk briefly about selecting the cables and wires and how to properly choose the correct size of wire depending on the application. So let us start. To simplify it, I will categorize cables and wires in 3 categories. First of all, the single core wires. Number 2, heat-resistant flexible cables, and number 3, multi-core armored cables. So, single-core cables or wires are mainly used for light and power circuits, for small light and power circuits, as you can see in the picture. Their annotation goes as CU/PVC or CU/LSF. As you can see here, Cu represents the copper part, which are stranded usually in the single core or solid copper, but the most commonly used type is stranded. And PVC or LSF, low smoke and fumes, represents the insulation, the outer coating. So it's simply copper coated immediately with PVC coating or LSF. PVC is polyvinyl chloride, which is the most commonly used coating, and LSF is a sort of low smoke and fume emitting type of polyvinyl material, which is used whenever wires are pulled in public corridors and in areas which are used for escape routes for the life and safety of people who are evacuating that area. These cables or these wires are usually pulled in conduits. So single core wires, when they are installed, they are either installed through conduits or trunking. So you would use them typically in conduits or throughout trunking, enclosed trunkings. They are used mainly for light and power circuits. For light, you would use typically 2.5 mm, and for power circuits, it's starting from 4 mm. 4 mm, 6 mm, 10 mm, 16 mm, depending on the application and the breaker size. The second type are heat-resistant cables. These cables are usually used for terminating the wire to the final fixtures, such as light fittings, water heaters, fan coil units, things which are usually tend to be hot or tend to have a higher temperature during its normal operation. So these cables are made to withstand this increased temperature. We have light duty heat resistant cables, heavy duty heat resistant cables, depending on the application. Usually the temperature rating is 80 degrees, 105 degrees, depending on the project and the project specification and what is the requirement in this particular project. And last and most commonly used type of cable are the multi-core armored cables. So a multi-core armored cable is the cable that you would typically use for laying on cable trays. Whenever you lay any cable on cable tray, it needs to be an armored cable, since it has the necessary mechanical protection to be laid on cable trays without being damaged. So multi-core armored cables are usually used for feeding the electrical panels, for feeding the mechanical equipment, the main electrical risers in a building, inside electrical rooms, in open areas, in mechanical plant rooms. So they are the most versatile type of cable. So when we spoke about single core wires, we said these wires are usually the small sized wires, which are used for light and power circuits, either in conduits. They are easily pulled through conduits since you don't have the armor, or in enclosed in trunkings, whether GI or PVC trunking. So now we are talking about the multi-core armored cables. These cables, what do they consist of? As you can see here, this is an example notation of an armored cable, CU/XLPE/SWA/PVC. So this is a steel wire armored cable. Let's go through them one by one. CU is the first part, which you are where you are specifying whether is it copper or aluminum. So Cu is copper in this case. As you can see, you start with the conductive part, which is copper. Then you move to the insulation, which is directly above the conductor. This is in this case XLPE, which is the most commonly used. XLPE, cross-linked polyethylene. So this can be either XLPE or PVC, but XLPE is the most commonly used type. So Cu/XLPE, this is the insulation type. Then you have the bedding. This way it doesn't go through the this is like a standard. It doesn't go through the cable description. Then you move immediately to the type of armor used. In this case, SWA, steel wire armor. You can see that the armor is laid in wire form. This can be either steel wire armor or other types, but the main type is steel wire armor. Then you move to the final component or the final cable sheath, the enclosing part of the cable, which is the outer part, the visible part of the cable, is the sheath. So in this case it's PVC. This one can either be PVC, it can be LSF, which is a low smoke and fumes emitting material, but again the most commonly used type is PVC. So we go again, let's summarize it here. Cu is the conductive part. This can be aluminum or copper, so it can be Al, for example, or Cu. Al would be typically used in single core cables due to its magnetic properties. Then /XLPE, XLPE is the insulation directly above the cable. This can be PVC or XLPE. It can even be let's say a fire retardant material, for example. Then you move to SWA, which is the armor of the cable. Okay, this can be any other type. It can be steel tape armor, for example, STA, but it's more expensive and not as common as SWA. You would typically see SWA in the vast majority of projects. Then PVC, which is the final, let's say, enclosing part of the cable, the outer visible part of the cable sheath. We call it the sheath. Okay, now again, here, since the armored cables are the most commonly used type, let's go through details a bit. So the armored cable selection parameters. When you specify a cable, you start by the number of cores. So either it's 1 core, 2 core, 3 core, 4 core, and we annotate it like that. 1 core, 1C, 2C, 3C, 4C, etc. Then you want to specify the nominal cross-section area, which is of course in mm square. So starting from 2.5, 4 mm, 6 mm, 10 mm, ranging all the way up to 300 mm. We don't use more than 300 mm. In that case, if we have a requirement more than 300 mm, we use single core 630 mm cables. Combination of 1 core 630 mm armored cables. We don't use more than 300 mm armored cables in the region. I have not seen, honestly, personally, any armored cables more than 300 mm. It's not commonly used in the region. Then you would want to specify the nominal voltage rating. So it's either wire 0.45/0.75 kV, or this is a standard annotation. This is usually for the lower current carrying conductors such as light and power wires. All wires have this annotation, or 0.6/1 kV, which is the heavy duty cables that can withstand the high current capability required for feeding main feeders, DBs, mechanical equipment, etc. Usually you would specify this for all cables, 0.6/1 kV. This all these are both these annotations are for low voltage cables only. Then the conductor type, as we mentioned earlier, which is the inner part here. This is either aluminium or copper. Then the insulation type, it's either cross-linked polyvinyl chloride XLPE or polyvinyl chloride PVC. This is the part. Each conductor has its own separate insulation, as we mentioned earlier in the previous slide. Then the cable is either unarmored cable, steel wire armored cable, steel tape armored cable. So the armored type, you need to specify it when you are selecting a cable. Then the outer sheath, as we specified again and explained in full detail. So these are examples. So for example, you would say 1 core into 4 mm Cu/PVC. This would be a wire. 1 core into 2.5 mm Cu/LSF. This is again a wire. Then you have an armored cable, for example, 3 core into 185 mm Cu XLPE SWA PVC. You would read it like that. Then we have, so this is a 3 core cable, 185 mm. Each core is 185 mm. When you say 3 core into 185, it means each one of these is 185. Please don't confuse this. So 4 core into 300. 4 core, 1, 2, 3. You would have a fourth one again here. Each one is 300. So 4 core into 300 means each core is 300. Not that 300 is divided over 4. No, this is a common misunderstanding. Okay. So then I will move now to the next part, which is cable and wire selection. How do you select the suitable wire and cable required for the application? Let's go briefly over each one of them. So we will start with the single core wire selection. As we explained earlier, single core wires, you would use them in a conduit. So for example, you would like to use single core wire for a light circuit or power circuit. So let's start with the based on our application and the conduit size that we have. You want to select the suitable wire size. So for light circuit, you can see here this table, this is table 1 in DEWA regulations. You can find it under appendix 5. So for example, let's say we have a lighting circuit which is 10 amp or 15 amp. So you look at the breaker size which you have. Lighting circuits are 10 amp or 15 amp. You don't have any other rating, 10 amp or 15 amp. So the size of cable in concealed conduit is 2.5 mm. So always for lighting circuit we use 2.5 mm wires. How many numbers we use? As we explained in one of our earlier videos in detail on the load schedule, you use 3 wires for each circuit. You have the you have the live, the neutral, and the earth. All of them are 2.5 mm. Then another example you have is a 20 amp breaker, which is a typical power circuit. You would use 4 mm. You look through the table here and you would use 4 mm. Again, if it's a single phase, then you would use 3 number 4 mm. If it's a 3-phase circuit, how many you would use? You would use 5, since you have the 3 phases RYB, and you have the neutral, which is again 4 mm, and you have the earth, which is again 4 mm. Then as you go here, you can see for wires you would usually go up to, let's say, 40 amps, and you would stop here. More than that will require cables. So I want to talk about the 30 amp. 30 amp, you can see here, if it's a single phase circuit you have a certain size. If it's a 3-phase circuit you have another size. So you look at your circuit. Let's say I have a 30 or 32 amp circuit. If I have a single phase circuit, if I have a single phase load, I would use how many? 3 number 6 mm wires. 3 number single core 6 mm. If I have a 3-phase circuit, I would use 5 numbers 10 mm wires. So please be careful about this. If you have a single phase circuit or 3-phase circuit, each one has a different size. Less than 30, both of them are the same. You can see 6 mm, 4 mm. 30 and 40, you would use a different size for 3-phase and single phase circuits. And the other factor that you need to keep it in mind when you are selecting single core wires is the size of conduit. If you look at the table here on the right side, is the size of conduit. So you can see here, for example, let's say for lighting circuits, I would typically use 20 mm wires, 20 mm, sorry, conduits. So you can see here the size of this factor, you need to keep it in mind when selecting single core wires. So 20 mm conduit can take how many? We said for lighting circuit we use 2.5. 2.5 mm wires, maximum of 5 number wires can go in 20 mm conduit. If I have more wires, if I have to use more wires for, I have multiple switches or extra number of points in this light circuit, I would go for 25 mm, which can take up to 9 number 2.5 mm wires. Again, you can see for the 32 mm. So you need to keep in mind the size of conduit, the suitable size of conduit, which can take the number of wires for your circuit. So for example, let's say I have a single phase circuit which is fed by a 30 amp breaker. I have 3 number 6 mm. So I look here, I need minimum 25 mm conduit for this circuit. I can't use 20 mm conduit. So that's it, the selection of single core wires in brief, of course, just as a basic guideline for people to look at and consider when they are selecting single core wires. So armored cables selection. Armored cables selection surprisingly is much simpler to do. You have another table, it's table 3. You need to be careful when looking at the cable selection table. Is what makes a difference is the type of insulation used. So this table I'm going to, since I'm assuming you are using XLPE insulated cables, there's other table for PVC insulated cables. XLPE insulated cables tend to withstand more currents, so you would use a smaller cross section for the same breaker size. So please, this is a very important point, don't make this mistake. Be sure to know which type of cable is specified in your project, or which type of cable. If you have the choice, I advise you to use the XLPE. The increased cost for XLPE insulation is accounted for in the reduced cross section, conductor cross section, which you are going to use. So depending on the application. So in this case, I'm assuming the XLPE insulated cables table number 3 in the DEWA regulations. So the step 1 in selecting a cable, of course, as we explained in one of our earlier videos, is to calculate the current, the load current. Then you would choose the breaker. Here you have the breaker. And finally, you will use the corresponding size for this breaker, the corresponding cable size, regardless of the number of cores. So, for example, I calculated and my current came to be, let's say, 52 amps, for example. Then I would use a 60 amp breaker, and the corresponding cable for this is 16 mm. So if I have a motor load which doesn't have any control panel, I would use a 3-core cable. If I have a load that is a DB or a control panel or any type of load that requires a neutral, I would use a 4-core cable. So either 2-core, 3-core, 4-core, again depending on the application and the load type and the starter type as well. So that's it in brief regarding the cable types and the cable selections. If you have any question, please let me know. And thank you for listening to this brief tutorial about cable types and cable selection. Thank you very much.